Hey everyone, now that I've cleared the integration techniques, it's time to move on to applications of integration. The first application is what we call by the definite integral. Alright, so what are definite integrals? So we recall, right, all the integration that we've been doing, right? It's just simply, let's say, integrate a function and then you get a result. So again, capital F, which means the final integrated form, plus a arbitrary constant c. So this is what we call by indefinite integral, right? So these are indefinite integrals, meaning that they take there's infinite possible solutions, right? But for definite integral, they have a final value, and it's actually a numerical final value. So for that, I'm going to show you that for definite integral, I'll be introducing to you what we call by the upper and lower limits. All right. So how do definite integrals differ from indefinite integral? Let's consider a very simple example. All right. Let's say we integrate x dx. We will get back x squared over 2 plus c. Right. In definite integral, you must add a limit, all right, on the upper and lower limits of where you want to find the value from. So let's say I want to find the value from 1:2. So this is basically read as integrating x from x equals to 1 to x equals to 2. Okay, so what do we do afterwards? It's very simple. Perform your basic integration again. So integrate x first, you get x squared over 2, right? Just increase the power by 1, divide by the new power. Now, the difference is that you add the square brackets, then you put the limit 2 and then the lower limit 1. And you do not add the plus c because you're going to get a definite answer, definite value. You're going to get one solution. Next up, sub in the values. How do you sub in the values? Very simple. First, sub in the upper limit 2. So I sub in x equals to 2, I get 2 squared over 2. Afterwards, you put a minus sign. You take the upper limit, subtract it with the lower limit. So sub in 1, I get 1 squared over 2, half. Then I will get 3 over 2, and that will be the final value of this definite integral from 1:2. So another example, let's say I have pi over 4 to pi over 2. And I think you can see where this is going. Trigonometry integration. So again, in indefinite integral, right? So you're just going to integrate cosine x dx. You just simply, sine x plus c, right? Same thing for here, all right? Perform the basic integration. Cosine x becomes sine x, right? Then because you have the limits, you add the limits. So preparing to substitute them inside to get a numerical value at the end. So you get sine pi over 2, which is basically 1, minus sine pi over 4, which is 1 over root 2. And at the end, you would get 2 minus root 2 over 2. Okay, I mean, I did a lot of simplification in my head. So you want to know it's just times root 2 over root 2. And then, yeah, basically this is how I get a final answer. All right, so this is basically the introduction to definite integrals. You'll see this a lot, especially in the application of integration, because a lot of the applications of integration uses definite integrals. All right, so yeah, there we have it, definite integrals.